Hi everyone, good afternoon or evening, depending what time zone you're joining us from. Welcome to the latest episode of the JavaScript Live, which is part of our live series webinars here at Amicus. For those of you who aren't familiar with Amicus, we're a niche tech recruitment agency specializing in JavaScript, Python and Golang across the US, London and Berlin. My name's Amber, I'm one of the recruitment consultants here, and I specialise in recruiting full stack and back-end JavaScript roles across the East Coast and also remote across the US. So today I'm joined by Bhargava Krishna, who is a senior software engineer at DAT Solutions. Bhargava will be taking a deep dive into JavaScript and Node, talking about server-side frameworks and AWS Lambda functions, and giving us a demo as well. So we'll have three main sections of this webinar. And after each section, we'll have a break for questions, as well as doing a little Q&A session at the end if needed. There is a Q&A box at the bottom of the screen. So as we go, please pop any questions you've got in there and we'll answer at each break. So enough from me. Without further ado, I will hand over to Bhargava.
Thanks, Amber. Hi, everyone. I'm Bhargava Krishna. I'm a senior software engineer at DAT. My specialty is I have been a full stack engineer for the past 5 years. Today in this webinar, I'm going to explain or go through what JavaScript, how JavaScript moved from the front end to the back end, how Node.js enabled developers to use JavaScript on the back end to build servers, and also some serverless technologies. So let me share my screen here. I've prepared a slideshow here. All right. I hope everybody are able to see my screen. Amber, can you see my screen? Awesome.
Yeah, I can do.
Let me do here. Like I introduced myself, my name is Bhargava. Again, senior software engineer. Here are the topics that I'll be covering today. We have 3 topics. Everything you need to know about Node.js. It's not everything, but I'll do my best to explain what JavaScript is and how Node.js is relevant. Then we have how to create REST APIs using Express Server and serverless programming using JavaScript functions here. All right. So first of all, fundamental JavaScript is single-threaded. So when we write JavaScript programs, we don't usually care about maintaining threads and making sure, like, it's all on a single thread, so the execution happens from top to bottom, one line at a time. So what are the characteristics of a single thread programming language? One is it's a one call stack, one memory heap, and code is executed one line at a time. So if you look at this sample program here, I have a function that returns greetings based on time. You see how, so when you execute this particular function, it creates a new date object, gets hours, and then looks for what the hour is, and then returns a greeting. You see how this function goes line by line and then returns. And as soon as you return this, this whole object is garbage collected. So this is the nature of single-threaded. Nowhere here you see any event loops or anything callbacks. So the single-threaded nature of this. Now, this works well on the front end, but when we go to the back end, when we use JS, if you want to use JS on the back end, we have to make sure it's scalable for network applications for input-output, because a lot of them are blocking. Some of them take time, like if you're sending a request on the back end from one microservice to another microservice, it might take some time to get the response back, and we don't want that to be in blocking nature. So that brings me to what is asynchronous versus synchronous programming. So asynchronous programming is basically non-blocking in nature. So we don't want, when we, let's say, for example, in a typical server environment, when we send a request to the server, we don't want that request to take long just because some of the computations are taking longer. We want that to be non-blocking in nature. So how do we achieve asynchronous features on the backend? We use callbacks, promises, or native JavaScript async await. Example for asynchronous function is Node.js. Like if you have worked with Node.js in the past, you'll know reading a file can be of two types: synchronous and asynchronous in nature. So if you use this example file system, read file asynchronous, it will read the file and then it will have a callback that will trigger when the reading of the file is complete. People tend to mostly use this. There's no reason to use sync nature, but it depends on the use case. Coming to synchronous functions, blocking in nature, like I said, and then we also have a way to do that in Node.js using synchronous way of reading files. So the reason I talk about this is because I think the way Node.js does asynchronous has changed other programming languages to actually implement asynchronous. Like Java, I think, also has asynchronous way of doing the programming. So it is revolutionary in that aspect. So now going back to, now we know what asynchronous programming is, and then synchronous. And we have to learn about parallelism and concurrency. And then I'll show you how Node.js can be leveraged, or any JavaScript runtime can be leveraged to use both to get the maximum efficiency out of the programming language, and also the resources provided to us to run our servers. So let's say for parallelism and concurrency. So what is concurrency? Let's assume there's one processor given to us. Let it be a cloud. It can be a Mac. It can be a computer, a personal computer that has, let's say, one core. Now, let's say we have two tasks, red and green, and we want to execute these two tasks. The way OS operates when it has only one core to perform these computations is it switches between task A and task B. So it executes task red, then it executes task green, and then maybe if you have asynchronous in there and it's waiting for other responses to come back, it continues with other tasks, and then you get all the output. But with parallelism, let's say you have two cores. Now, if you have two tasks or two processes, you can execute these two processes on two different cores and get the output for it. So parallelism can be achieved by having more resources, basically more cores. So that is basically horizontal scaling. The more resources we add, the more things we can run. So now I will show you. So first of all, let's go to runtimes. So now we know JS is single-threaded, and it's usually primarily used on the front ends to build UIs. Now, how do we make? How did the developers take that programming language and create an environment on the backend to run the servers? In 2009, like you all know, Node.js was launched. Node.js is basically, Chrome has an engine called V8 engine that they took, and now you can deploy, made a framework out of it called Node.js that you can use on the backend to run a server. So Node.js is basically an asynchronous, like I explained what asynchronous is, event-driven. So like when we have a task that is taking a lot of times, you can put it into an event loop, and once that task returns the data, it triggers back a callback, and then that Node.js continues executing that function from there. So that is event-driven runtime environment. So a Node.js is an asynchronous event-driven JavaScript runtime. Node.js excels at input-output type of services where we don't have a lot of computations performed. So like if you want to run AI models or something like that, machine learning models, Node.js is not the programming language I would suggest you should go for, but Node.js excels at just request response, getting data from the databases and stuff like that. The key characteristics of Node.js is, like I said, event loop. It's non-blocking input output. It runs on V8 engine, and it also has a package manager. So one of the ease of developers getting into Node.js was how easy it is for people to publish packages and consume packages using Node.js package manager, NPM. And it is built using the environment, the runtime environment is built using C++. But Node.js is not the only framework for JavaScript runtime, server-side runtime. We have a new framework called Dino, which is relatively new. It is also created by the same person that created Node.js. The way it differentiates itself from Node.js is instead of C++, they use Rust, which they claim is faster. I've never used Dino before. It is a bit more secure, so all the permissions have to be explicitly granted versus Node.js, where you have to implicitly disable the permissions. And yeah, it's built using, it's more secure, and it also uses V8 engine. So now, I think I did not create one slide, but I want to explain how these all tie together. So now we have single-threaded, non-blocking input-output, event-driven architecture. So every time you send a request comes in, if it's taking way too long, that request is put in the event loop, while other requests are honored, and then that's how Node.js performs better. But the other way, so that is only one core. So Node.js with this architecture alone is really efficient in giving out the output, delivering the output as quickly as possible. But then if you want to leverage more cores, you can run Node.js in cluster mode. So basically a cluster mode is, let's say, usually most computers have more than one core. So if you want to use all the cores, let's say in cloud, you've assigned a basic minimum computer that has 2 cores. If you want to leverage all the cores, you can run the same program into multiple cores. That way, Node.js can do asynchronous requests, but also have a parallel Node.js program running that is also handling more requests. So that helps you handle a lot more data, a lot more requests. Let me stop sharing this. I'll show you there's a framework called, you can do it using basic Node.js built-in cluster mode, but I think this PM2 is a default. I mean, it's one of the tools I've used as cluster mode. It shows you what strategies we use. I'm going to run a program using this, and I'll show you how we can do this. But there's a lot of documentation explaining what this PM2 does. But yeah, we can run a Node.js in cluster mode using PM2 to leverage full potential of our computer resources. So any questions so far?
I can't see any in the Q&A box, but everyone watching, if you do have any questions, there's a little Q&A section, and we can jump in to answer them, but I don't think there's any at the moment, so feel free to keep going.
Awesome. So here's the diagram they have on this website, PM2, that shows you exactly how you can run Node.js in multiple cores. If you have 4 cores, you can run it on 4 cores. The only downfall for this, you can see, is the RAM will be shared by multiple processes. So you have to make sure that the RAM assigned to this whole computer is enough that all these processes can run without any problem. And also you cannot have a state. So you're storing data on a particular thread, like for example, session IDs. You have to use a third service or like a Redis server or something where you store the state, because you cannot there's no easy way to communicate between these threads. There are ways, but I would say preferring a third-party state management is a better way to go. All right, so that brings me to the end of the first part of what is Node.js. Everything you need to know, it's a single thread. JavaScript is single thread, but with a runtime asynchronous way of doing things, Node.js has enabled developers to bring JavaScript to the backend. Yeah, the second part of this is I'm going to show you two workflows. One is how do you deploy a Node.js? How do you use Node.js to deploy a server? And then how do you use Node.js to deploy a serverless architecture? These are two different ways you can use Node.js to respond to requests. So let me go to my program here. All right, I have a basic server that I built this morning. And I have a serverless program too that I'm gonna run and show you guys how the things work. So the way you create a server on Node.js is you just use commands npm init, and then you'll have a primary file called package.json. Basically, this is the source of truth for a Node.js server. And here, one distinction that I want to mention here that I think is really important for our webinar is Node.js in itself is not a server, it's just a runtime environment. You can create servers using Node.js, and that's where Express comes in. So you can actually just have any computational thing going on the back end using Node.js, but you don't really have to have a server in Node.js, but you can create servers using Node.js here. So I've installed two dependencies. One is PM2, like I showed you, that launches Node.js in cluster mode. And then Express is a server framework that you can use to create servers for HTTP request and response. And body parser is just a middleware that parses HTTP body. All right, so I have two scripts here. One is start when I run the script, Node.js will just run this index file, which basically has a server code that I'm going to show you. But if I run the script, say start cluster in cluster mode, it will go to this file and start the server in a cluster mode using the config I set up in this particular file. All right, let's go through what I have here in an index file. This is a basic server. You can set up your project however you want. However you want, but what I have here is an Express server. I have a body parser that's parsing JSON and URL encoded URLs. I am also limiting how much data this body JSON can have, which is 10 MB. You can limit it at application level. You can limit it at infrastructure level. So this is at application level. And I have a basic route that gets data, and then I'm listening on port 5050 here. So I have a process ID set up here for you to for me to show you how you can launch it in multiple processes here. So let me actually go through what these routes are and what it's actually returning. So we have a route called for get. So I have an endpoint that says get donut data. So basically we have a JSON of a lot of different types of donuts, and we want to return that data where this endpoint is set. I only have get request here because it's easy for me to show you in a browser. Then queries, usually they are DB queries. So here is where so like if you have a database sitting in a cloud, usually these queries get data from this cloud. So there's some kind of communication happening between your microservice and the cloud database. And depending on where the database is deployed, it might take a few milliseconds to a lot of milliseconds. And to mimic that, I just have a sample JSON here. This is my JSON data. To mimic database queries, I have a sample JSON here. It returns a promise. Like I said, I'll explain you how things are working using promises. But a promise is basically saying, get me this data. I will continue with my execution, but when the data arrives, please let me know. And that's what promise does. So when this is, when you see a promise, it's put into an event loop, and the JavaScript continues with other requests or other execution. And when the promise returns the data, it resolves with the data or it rejects with an error. So you can either reject with an error saying, okay, I could not get data from the database, in which case the JavaScript execution still finishes, or resolve with the data. Here I'm just using Node.js's built-in file system to read file asynchronously right here. So I have a path to my file, which is basically data sample.json. I'm reading this file. And like I said, when read file is asynchronous, it's not synchronous. So when JavaScript sees this, it knows it has to put this into an event loop. And then there's a callback for this that either returns an error or returns the data. Think of it like coffee shop receptionist. When you order something, since the receptionist cannot prepare your coffee, she just puts it into the order of into your queue, and then she takes the next order. So JavaScript does that, and this particular function is basically the one that is put into the event loop, and when the data is returned, it calls resolve with the data. All right, and then I have just a controller that I am using to get data, but I also want to filter specifically based on name. So the type of data we have here is different types of donors, but if, let's say, a user requests data based on, let's say, name. Let's say we want to filter out based on name, if it's a cake or raised, or we have other things, old-fashioned, we have to filter that out. Usually you do this at the database level. It's not a good idea to do it at the app level, but I'm just trying to mimic the input output here. So I'm doing it at the app level here. All right. So far, any questions?
We've not had any come from the Q&A box, so yeah, feel free to carry on. As I said, guys, if you do have any questions at all, drop them in that Q&A box. There's in the toolbar, and we'll get around to answering them.
Awesome. All right. So do you guys see my command line here? We have one question there. Let's see.
We do indeed. So we've had a question that is, why is it bad to use filter over a DB query?
So that's a really good question. The thing we need to understand is the amount of data that I have right now is nothing. So in a usual like a real life scenario, we'll have tons of data, and you cannot actually filter data without indexing. So a database has a lot of ways for you to do a lot of like computations depending on what database you're using. So like, for example, if you know one of your requests is that people might ask a type of donor based on name, a database administrator, usually a person that is taking care of the database, might design it in a way where he indexes name. So you don't have to filter it here, because if you filter it at the level of the programming, first of all, you have to get all the data into the memory, because Node.js is basically running on a computer. And now memories usually are, let's say, for example, 2 GB, 6 GB, like depending on how much you assign. You cannot download the whole database into memory and then filter over all the data, because it will, if there are millions of records, it will take forever to go through all the records to actually get the objects that have name, cake or something, for example. So it's not always a good idea to get all the data into the server. That's why we cannot use filter, because filter only works when we have all the data available on the server. I hope I answered your question here. Awesome. So right here, so I have a server. Basically, the files in the server are exactly what I have here. Server, I have 2 folders here, server. So I'll show you 2 ways to launch this Node.js server, and you will know the difference. So I'm using a MacBook Air. I think I'm not sure how many cores they have, but I'm pretty sure they have more than one. So I'm going to launch. So when you launch Node.js server, you can, like I said, we can decide to launch it in single threaded or in a cluster mode. So here, if I run, I have 2 scripts. The way you start a Node.js server is you run the scripts, and you have a default, like you have a command that it needs to run when I run this script, and we'll run that script. For example, if I say node, so if I say npm start, so when I hit npm start, it will run this particular command. And right here, it says node index has been run. And now app is listening on the port 5050 with the process ID this. Where do we get that from? We get that from here. So it says, so I have logged what I'm doing here. So when the server starts and I listen to a port, which is this particular port 5050, you can either have it in a config file. This is basically a config you can set up, or if that's not available, use port 5050. And now when I'm using port 5050, I just want to log what port I'm running my app on with what process ID. I got the process ID. So just so you know, this process.pid is enabled by Node.js. So that's what runtime environment provides. So all this process and other things are objects that Node.js provides that you can use. Like, for example, if you go to package.json, have 3 dependencies here. These are the only 3 dependencies that somebody else created and posted them on a package manager that I thought I needed in my application. So I basically downloaded it into my application. But if you go to this particular file, where is this? Here. If you go to this particular file, fs, path, these are 2 that are provided by Node.js environment. So that is what, when I say Node.js enables JavaScript to come to the backend, where it provides a runtime environment to do stuff. So when you're on the backend, you need an ability to read files, send HTTP requests, and everything. So right here is an ability for you to read files. And this is an inbuilt Node.js module. But if you think Node.js doesn't have any modules that meet your use case, you can always go to npm package manager and find something that that you think will meet your requirement. For example, Node.js has an inbuilt server module, but it's too convoluted. It's really difficult to use. So I use Express Server. That is a wrapper for the HTTP server module. All right. So going back to here, so I'm just starting a server and I'm logging which port am I listening to. So it's really important that when you start a server, it's always listening to a request. Which port am I listening to, and what was the process ID? So now if I go to 5050, port 5050 on my browser, I should be able to send a request to a particular route and get the response. And the route I have is, and that's one of the reasons I use get here. So I have a Safari here. I open a new tab. So similar to how you have localhost 50/50. So localhost 50/50 is, so I'm listening to my particular computer. I'm sending a request to the port 50/50 on my computer. Usually this part is somewhere a cloud address or an IP address to a remote computer, but the structure is same. So this localhost pointing to my own computer, I'm requesting 50/50. But if I request localhost 50/50, there's no get response. So there's no endpoint at a default level. So anything you put in the browser is default get. So now if I go back here and I hit this, I get the data. So I get, let's search for name here. So you see how there is raised, old-fashioned, and cake. I got all the data. I got all this data when I just put this in the browser here. So now I also said we can filter out based on what we want. Now, if I send a request with a query parameter, so there you might have seen if you go to Google and everything, usually the pattern is you go to someplace Google and then you have a query parameter. They assign a query parameter, but here I'm showing you how it's handled. So if you have this query parameter, you can detect that in your app that says, so if a request has a query param with a keyword name, which is this right here, pass that value into the function and please filter that out. So I'm passing that name here, and then I'm filtering the data for all the cakes, for all the donuts that have the name, whatever name I'm sending. So if I remove this part, you see the data increase. But as soon as I add that part, you see I can only find one, which is cake, because I asked for cake. You can ask for anything there. Let's say you ask for XYZ. What do you get? Nothing, because there is no donut with a name, whatever I typed here. So that's a basic front end to back end JavaScript. So now you can, let's assume you build a beautiful app on the front end, you're using JavaScript. Now you can also build a back end that basically responds to that front end, and every front end needs a backend service. So this is Node.js filtering based on data. So now, as you have seen here, I have only one Node.js process running. So you and I can, like, there can be thousands of users using the exact same app, meaning this particular app is getting thousands of requests, and everybody's requesting for, let's say, this particular data. Everybody gets this data. And the good thing about Node.js is it's non-blocking, so multiple people can concurrently request the data and it's served that way. But how do we make it more efficient? So right now, my Mac computer has more than one core and I'm not utilizing it. I mean, my personal computer, I use a lot of other apps, but if you have a cloud environment or a remote computer that is dedicated to just running this particular server, a Node.js server, there's no other app running on that. We want to maximize the resources utilization to make our app as efficient as possible. So I'm going to show you how we can launch this app in a cluster mode. So if you go back to my my scripts here, this is to start it in a single thread environment. If I want to start in a cluster mode, npm run start cluster, you can see how my app will be running in two processes now instead of 50-50, my app is now listening on 3000. And these are the two processes that are running here. So if I go back to my app, you see how this is 50-50. If I hit enter, it should fail. Nothing comes up. But now if I go back here and I change it to 3000, because now my cluster mode is running on port 3000. The app is the same, the endpoints are the same. It's just that my cluster mode decided to listen on port 3000, and my single threaded one decided to listen on 50-50. So if I hit 3000, you still see the same response. That's good. But you, as a human with a naked eye, we cannot see the difference between difference of efficiencies between these two. And I don't think it's visible until you load test it with a lot of concurrent requests. That's when you feel the difference between, you can see the difference between running it on a single thread versus in a cluster mode where multiple processes are handling. And how do we know which process is, so only one of these processes is going to respond to my request. And how do we know which process is responding to my request? Well, it depends on this particular cluster implementation. It's just round robin. So round robin is basically, I give one task to you. If you're busy, the next person gets it. So since there are only two, if this process is already responding to a request, the next process gets the next request, and so on and so forth. If there are 1,000, 500 go to one and 500 go to other. Now you can launch it in, so if I go to ego config, so this is the cluster mode config right here, what I have here. This is specific to this particular module library for cluster mode. Node.js has its native, but for this particular, that particular module reads this file and says, okay, he wants me to run this script, index.js, which is what where the server is at, server config is at. He wants us to run it on port 3000. That's cool. How many instances does he want us to run? 2. So you can change this to 4. So as soon as I change this to 4, I'll show you what happens. But before that, we have auto restart true, meaning if for some reason our servers breaks down, we want to auto restart. This is really helpful to make sure you don't get page not found errors on the front end. Let's say you requested Google for something. If Google said, okay, I don't know what's happening, but I cannot get your video or something. We don't want that to happen, auto restart. But this only works if there are no errors. If the errors happen infrequently. If the errors are happening frequently, no matter how much auto restart you have, the app will be buggy. Watch, basically what this does is it's saying if there are any changes to the server code config or anything, please watch for it and restart the server like that. Execution mode cluster, I think you have other mode not running cluster, and how much memory should you assign. So my computer right here has 6 GB of RAM, but I only want to allocate 650 MB of memory. If my app is taking more than that amount of resources, restart my app, and restarting an app will put it back to 30 MB or something. I think for Node.js, and ignore watch, which is just saying don't restart my server if any of these files change or this folder change. So now I change this to 4. If I restart the server, it should automatically restart the server. As soon as I change the file, it should restart the server. Let's see, it restarted the server, but it did not take the config here. Let's hope this one. Okay, right here. Restarted the server, but it did not actually restart it using the new config. So you have to have an external service that restarts it with the config. Right here, now my app is listening on 4 different has 4 processes that they are listening on 3000. And this library takes care of round robin. You can have other algorithms to assign those requests. It still should work here. But the thing is, you won't see any difference because, again, like I said, you have to load test this with sending, let's say, mimicking 10,000 users, sending 10 requests each. Then you'll probably see the difference in how it performs on a single instance versus multiple instances. All right, so far, any questions? So let me recap what I said. What is JavaScript? It's just a single-threaded programming language that we use to code or perform some computations. Now, how did it come to the backend? We use Node.js environment or ecosystem to use JavaScript and run a server on the backend. So how is it different from other servers? Node.js has something called event loop that performs operation asynchronously. So it's not waiting for the request to complete before it responds. That's why it's relatively fast, even on a single process. But if you want to maximize how Node.js performs in a real environment, you want to probably launch it in cluster mode. Usually, on this point, I want to tell you a big F here. Usually, you don't launch it in cluster mode. It depends on how the architecture is set up. In a cloud ecosystem right now, things are automated. So yeah, that's a good question. That's where I was going. That's where I was going here. So
yeah. So we've just had the question, just read it aloud if the recording. So PM2 library is taking care of servers like Kubernetes do.
No, that's what I was going to answer here. So PM2 is at application level, and Kubernetes is at infrastructure level. So what happens is, let's say we have Kubernetes, and Kubernetes is orchestrating pods. We call them pods, which is basically Node.js containers on multiple computers. So if the traffic increases, Kubernetes increases number of pods. But on each pod is basically sitting a virtual machine on inside. Each pod has a virtual machine. On this virtual machine is where you can run PM2. So basically what I'm saying is, if you know what the configuration is for a pod, let's say a pod has 2 cores, and we know each pod has 4 GB of RAM, you can technically use PM2 on each pod to launch 2 processes that handles any request that is coming to the pod. But the Kubernetes doesn't know what you're running inside the pod. This architecture is inside the pod. You can choose to do it, or you can choose not to do it. There's no HUD. Let's say a pod gets corrupted, 2 processes will die right away. That's the only drawback I see from an infrastructure point of view. But like Kubernetes will just get a false sense of metrics. If you're running 2 processes there, the RAM usage might be high. So Kubernetes might be like, oh, why is the RAM usage so high for running one particular process? So you have to work with it, like the infrastructure person should know what's happening there. It doesn't hurt to run 2 processes. Kubernetes does its own thing of horizontally scaling that. But on any single pod inside the virtual machine, you can run 2 particular Node.js servers. Hope that helps. Awesome. That's what I was going to mention. So you can. This is not necessary. So all these design choices depend on the company. Like the developers can discuss. But what I'm saying is, other programming languages by default leverage all the cores. That's how they have multi-threaded architecture. Node.js doesn't have a multi-threaded architecture. So if you want to leverage all the cores and span, use all the resources available to you, there is still a way to do that using Node.js. It's a question. Awesome. All right. So that's how you can do servers using Node.js. Any questions? Any other questions? Awesome. Now I'm going to show you serverless architecture. So there has been a new development in how requests are responded. Usually you can have a server running for anything. but it doesn't make sense if the server is not getting a lot of requests and it only happens periodically. Like I said, server always listens. So once you start a server, it's listening on the code. So the computer is using the computation resources all the time. The program is using computational resources all the time. If you don't want that, we can have a serverless architecture where you can send a request and get a response back. But as soon as the response has been sent, the program shuts down, so the resources stop being utilized, and until the next resource comes in. And you can use, you can do that. There's a lot of cloud native solutions to that. I've used AWS Lambda before, and I'm going to demonstrate how you can do that using AWS Lambda here. So usually if you have a server, you deploy it on, like again, you can use Kubernetes and other automation tools, but at the end of the day, it's being deployed on an EC2, a virtual machine. So your server will be deployed on a virtual machine, basically, which is a computer in the cloud, or you can be your own computer. On a serverless architecture, you don't have to worry about how much resources you have to allocate to the virtual machine and everything. You just have to deploy a function and tell this enabler that when the request comes in, just perform these computations and respond with the data they asked for. So for this architecture, it's the same. We have a package JSON, just like the server. I think I made this point clear a few minutes ago where I said Node.js is just an environment that enables to develop a server, and Express is the server. I made that point really clear for this exact reason. Here, if you look at the package JSON, you don't see any dependencies here. Nothing. I just said the name, description, and what node version it needs to run. If available, please run 17. That's it. Nothing else. No module used or anything. For this particular serverless function that I have here, it's an example. You can have more modules. So let's say your function needs to get data from an external source. You can get it, but this doesn't have it. But you probably most likely won't have a server like an Express or Micro. If people have used Micro before, you won't have a server on there because your function will be deployed on a server. So what I have here is similar. I have a main function. Oh, this is specific to AWS Lambda. They want you to have the structure where you have a handler and a main function. An event is something that you can send when you're triggering the Lambda. And that's it. The main function just executes a function that you want and gets the data. And every other setup is the same. I have an app here that has a database query that mimics the database query, but right here, I'm just reading the file exactly same what I showed you before, and the same data here. So I have the serverless app here. So there are like in a real world scenario, you usually automate this stuff as soon as you push this code to your source control. You have CI/CD that runs all the necessary checks like test cases and everything, and then creates a Docker image, deploys them somewhere that then can be sent to the Lambda. I'll show you how you can do that here. I'm not going to show you how you do CI/CD, but the end goal, I'll show you the end goal here. So here I'm on my AWS page here. I'm in Lambda services. Let me go to Lambda here. All right, it's a bit laggy, but let's do this. All right, so I have a Lambda function. If I go to functions here, you see I've created. I only have one function. I named it webinar demo. I open this function. So a function is basically a piece of code that cloud provider needs to execute when you send a request. You can write functions in JavaScript, Python, so you can have different programming languages. Right now, I'm showing you how you can use JavaScript to write serverless functions here. So I've created this. I'm going to show you how. So you have to. That's a good question. I would say AWS. So there's a lot of services on AWS that give you basic things for free. So Lambdas are free. You don't even need to link everybody with an Amazon account. I think by default have AWS, but I might be wrong, but you can create an AWS account if you have an Amazon membership or Prime membership or something. And you don't even have to link your credit card to that. You can just experiment with services. So you don't really have to have knowledge about all the services they provide. You just need to have knowledge about things you want to use. Like, for example, there are primarily three things you probably will be using. S3 is basically like a Dropbox in AWS. You just store files on there. Lambdas are something that are new, but they're fairly easy to play on with, and then EC2. So if you can read through what these three are, EC2 is a computer, Lambda is just a serverless computer that you don't have to manage, and S3 is just a place to store static files like photos. Let's assume photos or any compiled code basis. So to answer your question, you don't really need a lot of AWS knowledge, but the basic ones should work. You just go into Lambda, and you can fairly do this in like 1 or 2 hours. If you have code already present, I'm going to show you how you can do this. So let's say you have this exact piece of code on a computer. Without CI/CD, I'm going to show you how you can actually launch a Lambda function and put your code on the cloud and send that URL to your friends and let them access your app here. But in a real world scenario, you will automate this stuff. But yeah, so if you go to code, if you create a Lambda function, they will probably have a default code here. Don't worry about it. So here you can say how it gives me an option to upload a zip file, or I can select an AWS S3 location or URL that I can link to, that this will go and fetch the file from. Usually what happens is when you push your code to, let's say, GitHub or Bitbucket, the CI/CD pipeline creates a Docker image and stores it on S3. If you have a URL to that S3 where the image is sitting, you just paste that here, and then, yeah, the Lambda function is deployed. So Lambda redeploys with your particular code.
We've had the question, would the handler only run in response to an event? How would that work? Is it by something like a message queue?
I'm going to show you that. So the first point is the first step in the process is our function to actually have a piece of code, right? So a piece of code can be a zip file or a URL to an image on S3 location. I'll come back to this this person's question here. So let's say I pick zip file, right? Now I can technically upload it from my computer here. So local docs, I have webinar. You see, these are the two folders that I created. Let's just serverless here. This is just a demo version. This is not real life how you do it, but if you want to play around with it and get used to how these things work, this is how you do it. So okay, I think I have. So I'm going to create an archive file for this. It won't let me do it from this user interface, obviously, but let me do this here. So local computer, webinar, serverless. So I select this and I just compress them. So now I have a zip file here. If I go back here, I have the zip file. I upload and I save. Right? So now my Lambda has a function, but how does Lambda get triggered? So coming to that person's question. So we know now we have an environment set up and we gave it a code that it needs to run. But what triggers that? Where there are multiple ways. So you have, let's say, triggers here. So Lambda has triggers, which basically are, let's say you want to create an Alexa app. If somebody asks you an Alexa question, run this particular function, you can trigger it using that. Or you can trigger it using API gateway. API gateway is basically a URL that you can send to people that does that. Or you can use a lot of triggers. So SQS, like this person is asking message queue. Yeah, if somebody posts a message to a queue, SQS or SNS, these are message services from AWS. If something happens, if a message is posted to that, please run this particular function. You can tell that. Usually, it depends on the use case. You can have any type of function. Like I'll give you an example. So let's say you have a front-end app that has images, a lot of images. Let's say Instagram has a lot of images. Now, every time somebody uploads their picture to an Instagram, you want to run a Lambda function that resizes image to multiple mobile sizes, because you don't want the original image to be sent to all different formats. You need a tablet size image, or you need a mobile size image, or you need a desktop size image. Usually you don't do it. You don't do this while upload. You do it when the person requests. There are different strategies they use, but I'm just giving you an example here. So now you say whenever somebody uploads something to S3, in this particular bucket is basically a storage area, please run this function. That's how we can say it. So you can use this. I'm not going to show you how we can trigger this function, but to answer your question, yeah, there's a lot of ways to trigger this function, and these are just the options you can use here. Going back here, did I answer your question? Okay, let's see why it's taking a little bit of time here. All right. So yeah, we have the trigger, but I'm not going to show you how to add triggers today, but I'm just going to show you how we can start this function. So what I have created is in the configuration. So once I uploaded my piece of code, so right here is a piece of code, like you can actually edit the code in this interface itself, but I'm not going to do that here. So this particular code, now it has tests, monitors, and everything. I'm just going to go to configuration, and I click on functional URL. So what Amazon Web Services did is it gave you an URL to this particular Lambda function that you can actually use to trigger this function. So if I click on this, there you go, you actually got the data. So that's as simple as that. So now the difference between this and the server I'm running is I really don't have to maintain my server at all. Here, I just deploy a function and I get the same result. People who are using this URL, usually you have custom domains, so people who are accessing this data don't even know how or what architecture we have to get this data back. But yeah, that's Lambda for you. Like I said, you can use triggers, and I think that's serverless architecture. Any questions?
No, I think we're good to move on.
Well, I think that's all I had here. Yeah, so we talked about how we can create REST APIs using Express Server, serverless programming using JS functions and AWS Lambda, I showed you. And then what is Node.js and what we're actually doing using Node.js, and that's it. If you guys want to know more about how more in depth about any of these topics, just hit me up and we can get on a call and go through that. I like sharing my knowledge with people.
Yeah, absolutely. Massive thank you, Bhargav, for obviously putting that together. and presenting that to us today. Really appreciate it. Someone's asked, can we get a recording? You absolutely can. The webinar has been recorded and will be posted to the Amicus YouTube page. So be sure to check us out, like and subscribe, and you'll also find recordings from previous webinars. I had a couple of people saying thank you. I speak to developers so often, but I always find it so fascinating to actually see the coding in action and kind of the actual process of what happens. So yeah, I really appreciate your time, Bhargava. Thank you for obviously putting that together for us.
No worries. My thought process here is like coding sounds intimidating until you know how to do it and you see the results. It's so interesting and you want to solve problems after that. So I'm always here to help. And there's 3 questions here. Could we get the recording? I think, yeah. I have GitHub, but most of them are projects that I've really based on good ideas, so I made them private. I'm gonna share if I have anything that I want to show public, but I'll look into that. But other than that, thanks guys. Thanks for being here. Just talk to Amber and I'll stay in touch.
Yeah, and as Bhargava said, feel free to connect with us on LinkedIn, follow up with any questions that you'd have at all. But yeah, thank you everyone for coming and joining, and have a lovely rest of your day.
So, bye.
Thanks. Bye.